Let's go ahead and evaluate the derivative of a trig function at a specific x value together. And to get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. Alright, so our original equation is this y is equal to sine squared of 3x. Finding the derivative of these types of trig functions can be a little bit tricky, so I'm going to go ahead and try to rewrite it to make it a little bit more clear. Try to remember that when we have this little sine squared, that really means that we can put the 2 on the outside here. It's really sine of 3x times sine of 3x. Now, finding the derivative of these type of trig functions can be a little bit tricky, so let's go ahead and use u substitution to kind of clean things up temporarily. So for now, let's go ahead and say let u equal sine of 3x. All right, this is just going to be temporary, but let's go ahead and make this substitution for now. All right, so imagine for a moment that this sine of 3x is just going to be u, so let's go ahead and make that substitution. And so for now, let's go ahead and just think of our equation as y is equal to this u to the second power. Hopefully this right here looks just a little bit less scary than it did before. Then we can go ahead and find the derivative. So we can write dy dx. I'm going to write y prime here. Y prime, let's go ahead and use that power rule. So let's bring that 2 in front. It's going to be 2 multiplied by u raised to the 2 minus 1 power, which is just going to be to the first power. Just going to write it for now. And then don't forget, we're going to have to multiply this by du, right? Keep in mind that we're going to have to use the chain rule here. So remember, u is this sine of 3x, so what's du going to be equal to? So if we find du, that's going to be the derivative of this sine of 3x. Now keep in mind that if we take the derivative of sine of a function, that's just going to be cosine. So we're going to have cosine here of this 3x. So that's going to be the derivative, right? But you also have to multiply that by the derivative of this inside function. So what's the derivative of 3x? That's just going to be 3. So if you go ahead and just clean this up a little bit, we can also say here that du is going to be equal to 3 times cosine of 3x. So that is a little bit tricky just because we kind of have the chain rule within the chain rule here a little bit, because if you go ahead and find the derivative of sine of something, that's just going to be cosine of that thing, but then you also have to multiply by the derivative of that inside function. So keep in mind the derivative of that 3x is going to be 3. Okay, so we use u substitution just to kind of clean it up temporarily. Let's go ahead and make some substitutions back. So let's go ahead and change this u back to this sine of 3x, and this du, let's change that to, or substitute it with this 3 times cosine of 3x. All right, so we have 2 times sine of 3x multiplied by 3 times cosine of 3x. Let's go ahead and clean this up a little bit and simplify the expression. Let's go ahead and multiply the 2 and 3 together. And if we go ahead and do that, we're going to have y prime is equal to 6 multiplied by sine of 3x multiplied by cosine of 3x. At this point, we now know dy dx. That's this right here. So this is going to be our derivative. And if you want to, you can go ahead and plug in this pi over 12 in for each of these x locations, and you can evaluate this derivative at x equals pi over 12. If you want to go ahead and do that, feel free to do so. You can go ahead and plug it in. However, I'm noticing here that we have sine of 3x times cosine of 3x. And if you think back to some of your trig identities, you might be thinking of the double angle identity. Now, I'm going to go ahead and show you how to use that double angle identity just for some extra credit here, or just to refresh your memory. But if you want to go ahead and do it the other way that I just mentioned, feel free to do so. So what is a double angle identity? It's that when you have sine of 2u, that's just equal to 2 times sine of u times cosine of u. Notice how we have sine of something times cosine of that same something, and that kind of looks like what we have right over here. The only thing is we're going to have to take these 3x's and change them to u's for now. And so different from the u that we used earlier, let's go ahead and say let's let u equal 3x in this case. Plugging in 3x into this u right over here, we're going to say that's going to be sine of 2 times 3x, which is going to be sine of 6x, right? That's going to be equal to 2 multiplied by sine of u, which is going to be sine of 3x. So we're going to write sine of 3x. And of course, let's go ahead and multiply this by cosine of that u, or cosine of 3x. Now notice the sine of 3x times cosine of 3x, that's exactly what we have over here, sine of 3x times cosine of 3x. So let's go ahead and take this equation right over here and divide both sides by this 2 so that we can make a substitution. So if we go ahead and divide both sides by 2, we're going to get sine of 6x over 2 is equal to sine of 3x times cosine of 3x. So since this is the same thing as this, which is the same thing as this, We can go ahead and rewrite this as 6, which is out in front, multiplied by this sine of 6x. That's going to be all over 2. All right, so we're going to have 6 multiplied by that. Now we go ahead and clean this up even a little bit more. The 6 and 2 can cross cancel to have 3. So we can go ahead and say that y prime, or the derivative here, is going to be 3 times sine of 6x. All right, so if we want to go ahead and write the fully simplified version of this derivative, you can say y prime, but I'll go ahead and write the dy dx if you like. We can do dy dx is going to be equal to, and we can go ahead and write it's 3 times sine of 6x here. Now, again, if you wanted to go ahead and leave it as what we had earlier, which is right over here, feel free to do so. But if you just wanted to practice using that double angle identity, hopefully that was a good refresher or just a good little practice in how to use it and practice using u substitution a bit. This would be a little bit cleaner version of the derivative. All right, so while we have the derivative here, we still have to go ahead and evaluate it at a specific x value, right? So let's go ahead and think back. We're going to go ahead and evaluate this thing when x is going to be equal to this pi over 12. So let's go ahead and make a substitution. So again, if you wanted to substitute this pi over 12 just into this derivative that we had right over here, you could have done so, but I'm going to go ahead and evaluate it in for this location right over here where we have x. So let's go ahead and make that substitution. All right, let's go ahead and see. So evaluating this derivative when x is equal to pi over 12, we're going to have 3 multiplied by sine of 6 multiplied by this pi over 12. Now for 6 times pi over 12, we can cross cancel. That's just going to be half. So we go ahead and say this is going to be 3 times sine of pi over 2. And keep in mind that when you go ahead and evaluate sine of pi over 2, that's going to be just equal to 1. So that's going to be 3 multiplied by 1. So we know the value of this derivative when x is equal to pi over 12 is going to be equal to 3. If you need to check what that sine of pi over 2 is equal to, you can look on the unit circle. That's where 1 came from. This 3 would be the value of the derivative of that y is equal to sine squared of 3x when x is equal to pi over 12. And just for good measure, you could have always just skipped the last few steps here and just plugged in this pi over 12 into these two x locations and go ahead and evaluate it, and you should also get that the value is going to be equal to 3. If you want to go ahead and do that just for good measure or just some good practice, feel free to do so just to strengthen your understanding a bit. All right, so that wraps up this example on finding the derivative of a particular trig function and evaluating it at a specific x value. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.